Okay, so let's look at the difference between integers and strings. Integers are basically numbers. These are things that you can do things to using math. So you have numbers that it could be 1, 535. Here we have a long string of numbers with a decimal point. When I say string, sorry, a long line of numbers here. These are all integers. Strings, on the other hand, are typically we think of text. So we have examples here like Taco Bell, 5 plus 2 equals 7 exclamation mark. So the point being here is that all this is just text that's printed in there. There is no math happening. There's no computational math happening. We have another string. Basically, you can put anything you want in there. A number can be a string. These are strings and numbers that are variables, usually, that you cannot do mathematical operations to. Integers, on the other hand, you can. Strings, which we won't get into too much, but strings have indexes. If you get into programming and you're trying to find a way to tell the program or the processor to go and get me a certain go and retrieve a certain letter from a part of a string of text, well, there's an index to it, and indexes in programming always start with 0 with a string, so it goes 0, 1, 2, 3, even the space gets a number, so 4, 5, 6, 7, 8. So in this case, T is a 0 and C is a 3 on the index. We're not going to talk about those too much, but that's how strings work. If you take programming any further, you'll eventually need to learn about them, and they're sort of, you know, one of the many it's part of the bread and butter of any programmer is using strings and indexes. We'll just leave it at that. We have if expressions, so we've already gotten to look at that a little bit with XSLT of doing basically conditional programming. Here's a way to do that. It's an if expression. We've already seen this command here. When we return, we're going to run an if expression. So we say if data is equal to whatever we're trying to match here. We have the the word match, but we could have Apple, someone's last name, whatever. If that matches, then we run a command that says data matches, and so this would be something that we would return that would print out to the user, would say your data matches. If it doesn't, then it's just else, and then you print out to the user again, data does not match. Just a quick example of how the if command works. You can add on to that. Here's we've retrieved our XML data, our nodes, and then we're going to return, but before we return we're going to run this little if-else command. We're going to say if, in this case we're going to say does our variable data equal Apple, so it's going to go through all these info nodes and find out those info nodes that we put in data. We're going to say does any of those nodes inside of data equal Apple. If it's true, then data matches, and that will be printed out. If not, it's going to drop down and do an else if, and then it'll say does data equal oranges or orange. If so, it'll print out it's true. If it doesn't, it'll say something data does not match or data matches citrus. It'll be some kind of response like that. If it does not match apple or oranges, then you could keep dropping down indefinitely, but eventually you're going to have to stop this checking and say there's an error or something like there is no data matches what you want or something like that. So it has to return something eventually, and you end that with an else. When we do our final project, I think I have you do something similar to this for checking player names. I think that's what's in the exercise, but it's something where you're checking some kind of criteria. Does it equal this or this? And if so, then you grab it. If not, you just ignore it. So that's the conditional commands for XQuery. We have functions. We've seen these functions with XSLT and XPath, where we could do the sum, we could count, but we can do other things. We can do starts with, index of, contain, string join. again, these are things I just want to make you aware of, but we're not going to be really dealing with indexes. That's really beyond the scope of this class, but just want you to know that XQuery is a very powerful language, and we're just skimming the surface, but you can go much further with it. It's a very robust language. But here's an example where you can use one of these commands. We already saw it once where, again, we have our go and grab the sales.xml file, but we want all the info nodes, put those in data, and then we're going to put data inside of X, and so we're going to basically switch from one variable to another. And before we do that, we're going to make all the information that's inside of data lowercase and then set it equal to X, and then we'll return X. So it's very powerful functions. We can also format the results in XML or HTML. So here's where the XQuery comes in, where not only can you query XML, but you can output XML as well as HTML. How you do that, though, is by not only using our element tags. This is an element, but would have a name like last name, for example, or SS num for social security number, something like that. But how we do that is by using the curly braces. And basically what that says to the processor is that, okay, over here is our XML, that's where we're doing our XML, and then when I show you a curly brace, inside of that is where you're going to do your XQuery work. So the curly brace, in a way, is kind of a way to distinguish and sort of separate your XML syntax and markup from your XQuery syntax and markup, and the curly braces are how you do that. Here we have basically we're going to return, we've done this command, we've already seen, we're going to return essentially like a little baby XML document, and we're going to mark it up. This would be a root node, it could be something like directory, seed catalog, what have you. We'd have elements in here, it could be seed name, cost, what have you. And then in here we're going to do our XQuery work where we have data. We're going to return some kind of value or whatever, or it might be a value and its attribute. Anyways, the curly brace is the main point here, is how you distinguish, separate basically your XQuery from your XML. You can put even more in here. You can actually start out, so we have our little baby XML document. We have an open and close curly brace. And this is saying, okay, we have some XML in here, but inside we're going to actually do quite a bit of XQuery work. So here we, again, do our command to get all of our info nodes, return, and then we're going to have some more XML. So we break into that, do our tag, and then we're going to have even more XQuery work, and how we do that, again, is with the opening and closing curly brace tags, and we've got the same here as well. And then we always have to close them out. You have to watch out for them. We'll look at this with BaseX, but you know, you always, just like we did with our opening and closing tags in XML, you have to be very mindful of your opening and closing curly braces, because if you open one up and you don't close it out, it'll throw an error on you. So what can it teach us about XML? Well, it basically, XQuery opens up, I think, a lot of new doors for dealing with XML. It makes XML even a more flexible data storage specification. Sometimes we don't know how data is going to be used in the future, so we may have, say, like our seed catalogs we created at the beginning of the course. We mark those up, and okay, we want to sell seeds from them, but maybe there's another use case that we want to use, but we don't know in the future. Well, XQuery allows you to basically adapt to any use case that might come up, where I'll just leave it at that. Use cases are essentially like a business case where you use it for one purpose in a business or an organization, and then some reason down the road you have to use it for another reason. XQuery allows you to work around that and basically mine that XML data however you'd like. It breaks the document-centric thinking that XML sort of fosters, and this is something we don't talk about too much in the class, but other than that, we've always pointed out that databases are very modular, and it kind of likes to have just sort of words marked up or organized by little pieces of data. Whereas XML tends to be more like a document. We have a root node, we have a lot of hierarchy in it, and it has a lot of context to how it's used. Databases don't really work with context, so documents tend to work by context. This is kind of a deep topic, but let's just leave it at sort of the main point being is that XQuery allows us to mine and kind of surgically remove and retrieve data from XML documents in the same way you would a database. And it basically further helps us separate this idea of a data storage container that XML is versus its display. So this is what XQuery is about. We're going to look at an exercise. The course only is just not even letting you in the kiddie pool of XQuery. XQuery gets very deep. It's very powerful, so I just wanted to introduce you to it. We'll see it in an exercise, a very brief exercise, and then it'll be on your final homework assignment.